Here we have a pretty straightforward integration problem. It's actually from a past final exam, April 2012. It's number 12b. So let's read the question. So it's the integral from 1 to 4 of 1 over root x times e to the root x. So even if you're not in Math 1505 and you're not studying for the final, this is still a good integration problem. So we have several techniques to solve definite integrals. We want to be able to identify which technique to use. So when we first look at this problem, we should see that there's two things multiplied to each other. So we start out with the 1 over x and the e to the root x. Now e to the anything with an x in it is always a good place to start for integrals, because we know that the derivative of e to the x is e to the x, and the integral of e to the x is e to the x. So that kind of stays the same. Now hopefully we can notice that so we want to go straight to the exponent in e to the whatever that exponent is. So in this case the exponent is root x. Now we know because of the chain rule, if we take the derivative of e to the something with an x in it, we just rewrite it and we multiply it by the derivative of that exponent. So if we just think about what the derivative of this exponent is right now, it's 1 over 2 root x. Well, hopefully that sort of sets off a light bulb, because this is a lot like the other part in the integral. So we should be able to set this up as a substitution situation. As soon as we have the derivative of one part is found in the other that's multiplied to it, we know it's substitution. So we want to set u equal to the derivative. To the exponent, which is root x. That means du, if we're deriving that, which we just found, is 1 over 2 root x. Now, don't forget that when we use substitution, we also have to change our limits. So, our first limit is x equals 1. When x equals 1, root x is root 1, so u equals 1. When x equals 4, we get the square root of 4, so u equals 2. U. So our new integral should be from 1 to 2 instead of 1 to 4. And we have e to the u, because remember we called root x u. And then instead of times by 1 over root x, we can say we're multiplying by du, but it's actually du multiplied by 2. So we can just bring that 2 out to the front. The reason it's du multiplied by 2 is because du is 1 over 2 root x, but we only want 1 over root x. So to get rid of that 2, we need to multiply. And then we have our 1 over root x. So now this looks like a pretty straightforward integral. We know the integral of e to the u is just e to the u, so this is 2e to the u. Again, you can check by deriving this answer. Whenever we get an answer to an integral, we can take the derivative of the answer, make sure we get back to the derivative of 2e to the u. Yes, that is 2e to the u. We're evaluating this from 1 to 2, and we're just subbing 1 and 2 in for u. So we get 2e to the 2 minus 2e to the 1. Or we could write it as 2e squared minus e. Could even go one step further, 2e into e minus 1. And so that's the answer. So again, we know that this is a substitution question based on the fact that the derivative of the second part, e to the root x, was found in the first part that was multiplied. Hopefully this is helpful. You can always reach out to arnoldtutoring.com with any other questions you have. Thanks.